Question 4. Saturated steam at 135 pounds enters a heating coil where it gives off 250,000 BTU per hour. After passing through the coil, it is discharged as saturated liquid. Find flow in GPM of water exiting the coil. So, in order to solve this question, we gotta find absolute pressure of steam. So, pressure absolute. In order to do that, we have to add atmospheric pressure to our gauge pressure. It's 14.7 for atmosphere. I usually like to round this off to 15 just to keep it simple. So final absolute pressure is 150 psi. Now type in steam tables and you go to the pressure steam table and you basically have to find enthalpy for liquid and gas. So go to the tables and you'll see enthalpy section, and the measurements for enthalpy are BTU per pound, LBM, mass. Now you're going to see HF, this is liquid, HFG, and HG. So HFG is the difference between gas and liquid. In our case, for 150 psi, our liquid is going to be at 330.60 BTU per LBM, and our gas is going to be 1194.47 BTU per LBM. So now we use this formula. Heat out equals to heat in. In our case, in order to find heat that gets discharged, heat in is going to be mass flow multiplied by difference in enthalpy. So if you draw the coil, so this is our heating coil, we know that our fluid comes in as saturated steam at 150 psi A, and it exits as saturated liquid at the same pressure, 150 psia. We know that the coil gives off 250,000 BTU per hour. This equals to our Q out. So 250,000 BTU per hour equals to mass flow of our steam into liquid coming in, multiplied by the difference in our enthalpy. So in this case, the difference in our enthalpy is F and G. So if you go directly from the table, this value is 863.83. If you want to subtract the two values between gas and liquid, you can do that as well. And the measurements are BTU per LBM. So now we obtain our mass flow in this case. So the mass flow BTUs will cancel out, and in order to obtain this, it's going to be the flow is going to be BTU LBM per hour. So once you have LBM per hour, you'll be able to cancel these two out, and the whole equation is going to be equal. In any case, the mass flow is going to be 289.4 LBM per hour. Now we do our conversion. So we convert this to gallons. So 1 gallon is equal to 834 pounds. You can find this in section 1 unit. So just go to the beginning of the PDF file and you'll be able to find this. So LBM is going to cancel that. We're going to get gallons per hour. 1 hour has 60 minutes. So this is going to cancel out. Just go back. And we're going to get 0.58 gallons per minute.